Okay, next one, let's look at example 14. Sketch a PV diagram of the following process. Okay, a 2 liter of ideal gas at atmospheric pressure are cooled at constant pressure. Okay, so initially kita ada a gas of 2 liter at atmospheric pressure. It's being cooled at constant pressure to a volume of 1 liter. And then expand isothermally back to 2 liter, whereupon the pressure is increased at constant volume until the original pressure is reached. Okay, so kita tengok satu-satu. Example ni sama macam example 13. So we have an ideal gas. Okay, we have an ideal gas. Initially it is at atmospheric pressure and volume dia 2 liter. So initial volume 2 liter, initial pressure is atmospheric pressure, bermaksud 1 atm at 1 atm. And then it is cooled at constant pressure to volume 1 liter. So it's being cooled at constant pressure, dia cakap. So pressure constant tetap sama 1 atm. Volume pula sudah decrease kepada 1 liter. And then it is expanded isothermally back to 2 liter. Okay, expanded isothermally back to 2 liter. So here being expanded back to 2 liter, whereupon the pressure is increased. So kita tahu expand isothermal T constant. Okay, dekat part ni T constant, bermaksud V akan berubah, P juga akan berubah. So P also changes here, but we don't know what value. So let's just put it as unknown now. Okay, but we know that it will be increased lah. So dia sudah mention dekat sini where the pressure is increased. Now the volume is constant. Okay, the volume is constant until the original pressure is reached. Okay, now the volume is constant, which is, kalau dia cakap constant, kita tengok previous value dia, 2 liter, until the original pressure is reached. Original yang initial 1 atm equal to 1 atm. Okay, so this is our process. Okay, so kita identify dulu setiap proses ni, what type of process we have. So here volume dia berubah, tapi pressure dia tetap sama. Pressure constant in this case. P is constant, meaning that it is isobaric process. And then from here to here, P is constant. So it is isothermal process. And then daripada sini ke sini, okay, 2 liter tetap sama, volume constant, pressure akan berubah lah. So dari sini kita tahu dia increase, dia sudah cakap pressure increase at this point. Dan kembali kepada 1 atm. So pressure kita berubah, tapi volume kita sama, V constant. So V constant is isovolumetric. Okay, so these are our process. So in order to sketch PV graph, kita kena tahu apa value di sini dahululah. So sama macam sebelum ni, kita kena compare. Okay, so macam mana mau compare? Keluarkan dahulu PV over T. Okay, so kita kena pilih 2 point yang mana V tidak constant, P pun tidak constant. Okay, so kita mau ambil point ni, kita pilih either kita compare dengan this one ataupun this one. Kalau kita tengok this one, V dia constant, this one and this one, so kita tidak boleh compare. Okay, V constant, kita tidak boleh compare. But kalau kita compare with the previous one, kalau tengok dekat sini, V tidak sama, P juga tidak sama, sebab kita tahu dekat sini dia akan increase. T saja yang constant, so kita boleh compare with the previous one. T constant, so kita compare P1 V1 equal to in this case P2 lah, kita pilih P2 kan. P2 V2 equal to P3 V3. Kita mau cari P3. So P2 is 1 ATM, V2 is 1 liter, P3 is, we don't know what is that, V3 is 2 liter. So P3 will be equal to 1/2 ATM. Okay, so kita sudah dapat value 1/2, 0.5 lah basically. So masukkan dekat sini, will be 0.5 ATM. Barulah kita boleh sketch PV graph. So sketch PV graph, lukis label. Oops, why is it not moving? Oh my god. It's not moving. Okay, sorry for that. Okay, so kita continue. Where is it again? Okay, kita mau sketch PV, right? So sketch label dahulu, label the graph first. Okay, dia hilang sudah tadi yang kita kira. So tadi kita kira P1 V1 equal to P2 V2. So P1 is, sorry, bukan P1 V1. P2 V2, P3 V3. P2 1, V2 1, P3 is what we want, V3 is 2. So P3 is 0.5 ATM. Okay, barulah kita label graph, sketch graph, label faksi dia. Okay, P against V. So P dia bagi dalam ATM, V pula dia bagi dalam liter. So guna je lah value yang dia sudah bagi. Okay, so dekat sini kita tengok V kita ada 2, 1, 2, 2. So kita label 2 dan 1 sahaja. Okay, 1 liter dan 2 liter. Okay, untuk pressure pula kita ada 1, 1, 0.5, 1. So kita label 0.5, this one 1 ATM. Okay, so let's look at the process one by one. Okay, first kita ada 2 liter 1 ATM, 2 liter 1 ATM sini. 2 liter 1 ATM, proses yang pertama. Kedua, 1 liter 1 ATM. 1 liter 1 ATM sini. 1 liter 1 ATM ni proses yang kedua. Yang ketiga 2 liter 0.5 ATM. 2 liter 0.5 dekat sini. Okay, 2 liter 0.5 ni yang ketiga. Dan yang keempat 2 liter 1 ATM. 2 liter 1 ATM. Okay, balik kepada yang pertama. Okay, so kita sambung saja daripada sini ke sini. Straight, don't forget the arrow. So from here to here, but it must be curve lah. Dia mesti curve, tidak boleh straight line. Then lukis arrow dia. Dan daripada yang ketiga ke empat, straight, lukis arrow dia. Okay, so this is the graph of P against V. If you notice, sama macam example yang sebelum ni. Okay, dia punya proses, dia akan always berbalik. Okay, stage yang keempat tu always berbalik kepada yang initial value. Dia selalu macam tu je lah. Just remember that this one must be a curve. Kalau contoh lah, dia daripada 3 ke 2 ni pun sama. Dia mesti curve. Okay, macam ni mesti curve. Okay, so that's all for example 14.